We'll go ahead and get started here. Welcome, everybody. I'll tell you a little bit more about Solar Oregon. So, as I said, I'm Nicole and I'm a program manager at Solar Oregon. And we provide solar and storage educational workshops and showcase events. We help with solarize campaigns. And we also help with policy advocacy around solar and storage across the state. We have an exciting upcoming event, the Go Zero Tour. It's one of our annual events. So if you're interested in learning about zero energy homes, come visit us again for that. That'll be on October 5th. And we're really excited to have this showcase event today. We have two great speakers. We've got Kevin Hockman-Chupp here from Zion Mennonite Church. And then we also have Kevin Gooley, and I'll just tell you a little bit more about them. So Kevin Hockman-Chupp is a 27-year-old member of Zion Mennonite Church. He has a Bachelor of Science in Electrical Engineering from OIT. He has worked for Siemens and then which used to be Mentor Graphics for 36 years and is a senior document manager. He is also on the board of Drift Creek Camp in Lincoln City, Oregon. And Kevin and family live 7 miles south of Canby and have 3 acres and a 500 square foot garden. So thank you, Kevin, for being here. We also have Kevin Gooley here, and he is an experienced solar consultant with a passion for smart, sustainable development. He provides specialized design consultations for commercial PV and energy storage systems, develops Oregon community solar projects, and works with nonprofits and developers in pursuing any and all available public and private funding to help finance their clean energy projects. Kevin is dedicated to advancing clean, renewable energy in Oregon for all types of projects and communities. So with that, I'm going to go ahead and turn it over to Kevin Hockman-Chupp to talk more about Zion Mennonite.
Well, hello, everyone. Welcome. So we had a project going for a long time, and so I'm going to stop a little bit with just where is Zion, some of the reasons why we've done this project, and then go into some more specifics on the project itself. And so we're a church of about 100, 120 people. It varies a lot by Sunday ever since COVID. We provide an online service, so some people do attend online. We participate in the community, doing things like bridging cultures, which is their mission is to strengthen community by bridging cultures through mutually transformative relationships. We do gatherings in parks in Canby. We've done trips to the beach, just ways to get the communities together. Also, we participate like in Mennonite Disaster Service, which is a national organization that does, I guess, the natural events, such as like the fire in Detroit went through. We worked on a couple of homes there, rebuilding, helping people rebuild. We're located about 3 miles east of Hubbard, Oregon, south of Aurora, out in a rural area of town or this country. And next slide. So Mennonites have a history of creation care and stewardship of the environment. A number of years ago, probably about 2019, a number of the members wanted to start addressing our rising energy costs. We were hitting approximately $7,500 a year for our electric bill. We wanted to also create an understanding of self-reliance around that with regards to our own energy needs, increasing the consciousness of the congregation with the use of natural resources. And then we also wanted to help with climate justice. So there's a little bit more of the story. In fact, I'll be updating it over the next week on our website that talks a little bit more about creation care. Next slide. And so for climate justice, on the Mennonite Church USA's climate justice homepage, it has a statement here I thought kind of just provide a synopsis of it, which is, as followers of Jesus, we seek God's dream of shalom for all people and all of creation, including our climate. Shalom requires that we seek justice and healing in our relationship with God, with one another, and with the earth that sustains us. And so I thought it was a good synopsis as to part of the justification why we were willing to spend the money for this project. Next slide. So you can see here our solar project here. We ended up putting it on a shed. To fund this, we had a number of different places we got the funds from. So we had a budget excess a year, and so we decided as a church to put that money toward the project. We had a number of different accounts between the cemetery, between other maybe like gifts that were given from estates and things like that. We pulled all that together to help give us a lump sum. There's also some seed money that came in from a couple members of the congregation who wanted to really emphasize this and help it get going. And then we made a decision early on that we were going to do lots of volunteer labor. And so I go through that a little bit more. I think you'll see some pictures, but basically, let me catch up my notes. Sorry. We had the professionals do the roof and get the plywood up there, get the metal up there, so that Kevin's organization could go ahead and start working on the panels. We worked on the vertical walls, putting up the wood and the metal. We insulated the wall on the west, so it'd be less heat coming in if you're standing there using the facility. We did some plywood sheeting, painting, added internet, the trenching we did for both the electrical and for the solar power. And then also we'll be doing landscaping this fall. And so we're doing all that through volunteer work to help keep the costs down. As for the location, we had several ideas of where to place the panels. We could do it on our main roof, which has cedar shakes, which would have had additional cost of replacing that roof or doing something on it. We had a gym roof that was facing south, but there was a couple extremely old trees. I mean, they were probably over 100, 150 years old that we did not want to touch. They were just part of the property when the church was first put on, and we wanted to leave those there. And then talk about ground mount as an option. But also in that picture in the background there, way back, there's a brown roof on a red building and a black roof on a red building. That black roof, building that's behind there, is actually a very old barn. It's a historic barn. And we were looking at doing the roof of that because it would have had no shading, nothing. But when we actually started looking at it and the quality of the roof and how old the building was, we didn't feel the building could handle the weight. It's like a 2 to 3 story high barn, and we just thought it'd be safer not to do that. So we ended up deciding on doing a shed. And I talk, I think, a little bit more on that. Yeah, on the next set of slides. But with regards to locations, once we decided we were not going to do it on one of the existing buildings, we looked around with regards to where we could exactly place that building. We decided we wanted to have it accessible from the main buildings, which you can see there with a couple sidewalks. And we decided to put cement in there just so that it would have more year-round use. The structure is about 40 by 60 with regards to the area. And then with all the areas we were looking at around on the ground, we did a pros and cons list of each. With regards to installers, we requested bids from 4 different local solar companies. And we even looked at do-it-yourself. Then we looked at the cost, the overall proposal, and the continuing support from the company itself. And so that's where we ended up choosing Kevin's company. And so it wasn't just the cost. I mean, they happened to be the least expensive, but at the same time, we were looking at the holistic solution, not only just the cost. And then with regards to the final plan, we looked at different options for the structure. We needed, because you can see the picture, a fair amount of space. And so because of that, we decided to do a shed. So you had just one slope instead of doing a typical pole barn roof where you see it, where there's it's like a house roof. I mean, so we decided just to do this one section as one big long panel. And next slide. So with regards to that, it's a pole building, and that's fundamentally what it is. We put flat bottom trusses across every set of posts. We have the slope set up with regards to standard roofing. I think it's either 312 or 412. We wanted to have more use than just having this stuff on the ground, and so by having an outside structure, it gives us the ability to have church services outside. If someone would have a wedding or a reception outside, It's next to a cemetery, so that if someone was doing a funeral and didn't want to use the main church building, they would have a covered area that they could use. And then we also use it for our summer Bible school. And then why shed? Well, as I mentioned, none of the roofs were the correct direction without lots of issues like having replaced roofs or things like that. The ground structure would have added 20 or 30K to the cost of that. And so we decided to put that money into the building itself. And then the size was just the square footage that we needed to do that. Next slide. And you can see in this slide that we actually put a cement floor in, we reinforced it, we added sidewalks from the main structure out for ADA access. We wanted to be able to use the facility year round, and we just know that because this is on a somewhat of a slope, not great, but enough of a slope that there would be water seeping naturally through the ground under where the structure is. And we wanted to have a solid surface where people need to set chairs or a table or something like that. And so then we had a few Saturdays of volunteer work where we were putting up the walls after the structure was up. We did a cement footing around the edge just so that we were not having wood contact on the ground, which just make things last longer. Next slide. And you can see on the picture on the right, we actually brought the metal about halfway down the height of the truss. Once we got the building up and we were looking at it, we decided that we really wanted to kind of keep that open air feeling. Originally, the plan was to take the metal all the way down to the bottom where it is there on the truss, but we decided to go ahead and just stop halfway so it was a lot more open. It gives a lot more of a sky view, and then it's just a lot more light coming in naturally to the structure. Next slide. So that's the finished building. You can see there that there's room up on the roof still. We didn't use up the whole roof. We had a wall on the west side there you see. That's that solid big wall. That's because if you did anything in the evening during the summer, the sun would be shining in and you would be able to see anything that was going on. Also in the winter, because most of the storms come from the south and the west, it gives a little more shelter if from wind or rain. And so we did that. We put the control panel on the wall there. We can see the conduit coming out of the building. And it came out great. I mean, we're really happy with it. Next slide. And with regards to costs, basically the overall project is going to be about $205,000. The solar portion was $80,000. The cost of the solar shed, we like calling it that, the cement, which was more expensive than we originally planned, the electrical work, which I think Kevin's going to talk a little bit about the challenges we had there. We had a fairly interesting run to go. Anyway, that came to $125,000. And then with regards to incentives, the Inflation Reduction Act that we're in the process of applying for allows for nonprofits to get some of that money for solar projects. And so we are in the process of applying for that money, $24,000. Energy Trust of Oregon, $4,680. And then Mennonite Church USA Creation Care actually had a grant available to churches. They picked a couple projects a year. Our project was selected, and so we got a $5,000 grant for that. So approximately we had about $35,000 in incentives, which means our out of pocket would be about $170,000 that we had to raise and provide for the project.
Thank you, Kevin. That's great to hear that you were able to access additional resources to help fund this project. What would you do differently if you were to do a project like this again?
Well, that picture that I was showing with those trusses that came all the way down, one of the things we realized afterwards is that we should have used, instead of a regular right triangle, we should have done like what they call a scissor truss, or a truss that only would go about halfway down. And that way we'd have had not those low trusses that you saw there in that one picture. And we probably would have matched with that metal width. So that would just open things up and had just a little more larger feeling to the building inside. So that's one thing I'd recommend. If someone's going to do that next time, use like a 12-2 slope on the inside instead of just doing flat. That would raise it up.
It really seems like you're intentional about the design of this project and focused on open air. What were some of the other reasons to do open air versus a enclosed structure?
So we already have a sanctuary that can seat like 350 people. We have a fellowship hall slash gymnasium that is an enclosed space that we can gather in if we needed underneath closed walls. What we didn't have is an outdoor space, and we really wanted to expand out so we're not always in a building. And if we would have had this structure 4 years ago, we would have been meeting outside during COVID instead of just doing Zoom every Sunday. So we just wanted a different option, and we wanted to have it available to those of the community who might want to just talk to us about using that space in an evening or something, or just have some more flexibility with regards to the spaces we have.
What was the biggest challenge for this project?
Well, part of it is just asking for money is not always fun. I mean, the congregation stepped up with the funds. We started the Solar Vision 5 years ago. And I guess the time commit was probably a little more than we originally thought. It got, the 5 years wasn't heavy, but the last 2 years, just we were doing with the permits, you're dealing with the county, you're trying to get all of the contractors lined up and scheduled and going through it. So the last 2 years, for some of the group, it was more work. So that time was part of it. And the solar portion was a fixed cost, but we also dealt with the fact that the construction costs kept rising. Every month or two or three or four, we didn't get going on the project. It seemed like the cement got more expensive or the plywood got more expensive, those type of things. And so it caused a little bit of creeping with regards to what our original budget estimate was, but I think we were about $20,000, 25,000 from what we originally stated. We also decided to do a little bit more cement with the ADA work that we did with those sidewalks that cost probably another 10,000 for that. Yeah, those are the main things that were biggest challenges.
With all of these lessons learned, what advice would you give other organizations who are looking to add solar?
Well, and specifically probably nonprofit. I mean, one of the things that we did do early on was we asked for support from the congregation at a business meeting. We wanted to make sure that even though we didn't know where we were doing and how much it was going to cost, the congregation wanted us to move forward on the project. And so that was an important step, because then because of that, we did feel overwhelming support. I mean, there were some people who did not necessarily want the project, but at the same time, that's what the congregation decided, and so we were able to move forward with it. And based on that support, we kept getting reassurances from the leadership team throughout the project that things were going the right direction, that we were staying in line. We had lots of communication with them and the congregation. And so that was important, that we weren't just doing it off in the corner somewhere. We were trying to keep it in front of people, and we were being open with the costs and those types of things.
Well, thank you, Kevin. I really appreciate you sharing more about the project. And I think we're gonna go ahead and pass it over to Kevin Gooley to share
Kevin,
more about the specs.
yeah, Kevin too over here. Sorry, I'm getting over a cold, so my voice is a little cracky. So apologies up front. I'm gonna just go into some project specifics, get a little technical for all of you, but I'll try not to have your eyes glaze over too much. I work for Elemental Energy. We built the project. It is a flush mounted system. That means it's follows the pitch of the roof. We're not tilting up the array at all. It is a standing seam metal roof, and I like this picture a lot because you can see where all the clamps are underneath the racking. Standing seam metal is really nice for us because we don't have to penetrate the roof at all to attach to the actual framing. We can just clamp to the seam itself, and owners honestly like that as well, since we're not, putting a bunch of holes in your roof. It's net metered with PGE. That means that you're going to pay the net difference between your imported power and exported power per month. If you overproduce for a given month, that is put into an energy savings account, is what I like to call it, and rolled over to the next month, so you can build up credit in the sunnier summer months and to use in the fall and winter months. This was a supply side interconnection. That means we interconnected at the main service gear between the meter and the main distribution panel. We actually tapped the CT can. If you've ever seen a large building, it's going to be a large can that's like right next to the meter, and that's how they monitor all the power that's flowed in and what they how they charge you. Now the really interesting thing about this project was that it was similar to a ground mount, meaning that the array was not on the same building that the interconnection was. So we did have to do about 75 feet of trenching. And you'll see later in another picture where the power ends up. Next slide, please. Just some overall system specifications. It's a 31.2 kilowatt DC system, 34.68 kilowatt AC. So the AC is oversized to the DC, and I'll go into more detail of that later. It was a 65 Q cell, 485 watt solar modules, two Solar Edge 17.3 kilowatt inverters, and that's the picture to the right there. Those are the two inverters. Next to that is a combiner panel where basically it looks like a distribution panel, but it just is where we combine the two solar inverters to send to the point of interconnection. There are 33 Solar Edge S1201 DC optimizers. Those live underneath the array, and there's one for every two solar modules. What that does is it controls voltage in the string and helps you maximize production. It also helps you combat shading issues, because in a string of panels, it acts like a set of Christmas lights. Like if one panel is shaded, it brings down the production of the entire string. Optimizers eliminates that issue. And with overall, the system is estimated to produce about 35,000 kilowatt hours a year. And if you go to the next slide, I took a snapshot this morning. This was the production from the system yesterday. You can see it produced 113.11 kilowatt hours. And you see the bell curve of production throughout the day. You see it spiking and kind of little peaks and valleys. That means it was cloudy, so clouds were passing over and blocking the sun. But still, getting 113 kilowatt hours, pretty good for almost fall, in my opinion. So yeah, next slide, please. Yeah, and so I wanted to bring this picture back up to point out a few things. One, you may notice that the roof does have a lot more space on it. And that was because that the system is designed to cover all of the existing demand right now, but there may be plans to add more electrical in the future to Zion Mennonite Church. They might replace a furnace, EV charging, things like that. And so we designed the system to basically, we can add 20 panels, and then we can also add one to complete one more string in one of the inverters. So I mentioned earlier how the inverter, the AC side was oversized to the DC side. That's the handle of future expansion. And also, if you can see on the main building in the right hand of this image, you see the conduit going up the roof. So that's the conduit from the solar, and it's going through the attic all the way to the other side of the building and then dropping down to the point of interconnection. So bit of a challenge there. Our electricians spent a lot of time crawling through the attic, but they did it. So yeah. So,
Thanks, Kevin, for sharing about the design. How did roof setbacks impact this design?
well, like I said, we did leave some setbacks, and that was to accommodate for a future solar array, or a future solar string, sorry. You do have to have setbacks on a building that will be occupied, and that's for fire safety. But this one, and Kevin, you can maybe back me up here, that wasn't necessarily the thing that we had to follow, correct?
Right. We originally thought we needed to, and so we kind of got lucky, and we actually have more expansion space.
Yep.
But we purposely put a 2-foot overhang on the building just to make it a little bit more attractive building. And that just gives us a little bit more space then to add in additional panels going forward. But yeah, originally we thought the county was going to require it. So we designed the building, we had every plans done, and we just kept going. They eventually said, oh no, you don't need it because it's not occupied. Okay, that's fine. So our building's a little bit larger, but we have expansion now, so that's nice.
That's great to see, like planning for the future as well, and thinking about how you can easily add to the system. If other organizations are thinking about future expansion, what are things they should keep in mind?
That's a great question. For one, if you don't have enough roof space, then system expansion isn't going to be a thing. So make sure you have extra space for an array. That's obvious. You need to design the electrical ahead of time to either accommodate extra strings or add a whole nother inverter. And yeah, you really just want to plan for and understand like how much power you're going to be drawing with future load, and hopefully design a system that can accommodate that extra production down the line.
Great, thank you. Well, that was really exciting to hear about the project and how you were able to overcome challenges to get this installed. We have some time for Q&A, so if anybody has any questions, please drop them into the Q&A. This presentation will also be posted on YouTube, so it can be shared and revisited